There are only a few galaxies that can truly be described as iconic: the Milky Way, Large Magellanic Cloud, Small Magellanic Cloud, Andromeda Galaxy, and one of these galaxies blessed with the iconic crown would be the Cartwheel Galaxy. The Cartwheel Galaxy seemed like a far-off fantasy for most of us before the Hubble Space Telescope graced us with an amazing first peek at this one-of-a-kind galaxy. And just recently, astronomers announced the release of new images and observations of the region where this galaxy is found, using the infrared instruments on the James Webb Space Telescope. Seeing this galaxy in a new perspective enables us to make new observations and provide new answers for what we now think has happened in a few 100 million years ago. So, sit back and let's explore this stellar galaxy and its new images in more detail. But before we dive in further in this amazing cosmic leap for humanity, hello there, and welcome back to the Discover Space channel, where we bring you the latest space updates and discoveries you won't want to miss. Be sure to subscribe if you haven't already, and let's get on to the video. The Cartwheel Galaxy is a spiral and ring galaxy located in the constellation Sculptor, around 500 million light-years away. Fritz Zwicky discovered it in 1941. The Cartwheel Galaxy is the dominant member of the Cartwheel Galaxy group, which consists of 4 physically associated spiral galaxies. Several studies refer to the 3 companions as G1, the smaller irregular blue Magellanic spiral, G2, the yellow compact spiral with a tidal tail, and G3, a more distant spiral frequently visible in wide-field photos. An estimate of the galaxy's span resulted in a conclusion of 150,000 light-years, which is slightly smaller than the Andromeda Galaxy. Zwicky regarded his discovery to be one of the most complicated structures awaiting its explanation on the basis of stellar dynamics. Scientists believe that the Cartwheel was once a common spiral galaxy like our very own Milky Way. It then collided with a smaller galaxy 700 to 800 million light-years ago. The Cartwheel Galaxy's structure is said to be exceedingly intricate and heavily disrupted. The Cartwheel is made up of 2 rings. The outer ring, which is located of immense continuous star creation as a result of gas and dust compression, and the inner nucleic ring, which surrounds the galactic center. The nucleic ring also contains a ring of black absorbing dust. Several optical arms or spokes are seen linking the outer ring to the inner ring, and are thought to represent spiral arms reforming after the collision. Observations demonstrate the presence of both non-thermal radio and optical spokes, but they do not overlap and have been proved to be unrelated to one another, indicating that they are distinct structures. Now, let us take a look at this image of the Cartwheel Galaxy taken by the Hubble Space Telescope. The galaxy was discovered on wide-field photos taken by the UK Schmid telescope and was then analyzed in depth by the Anglo-Australian telescope. This galaxy's cartwheel shape is the product of a cataclysmic galactic collision. The collision changed the galaxy's shape and structure, resulting in 2 ring-like formations, one enclosing the galactic core and the other framing the entire galaxy. Like ripples in a pond, the 2 rings spread outward from the galaxy's center. As the outer ring expands, it pushes the dust and gas that surrounds the galaxy outward, causing star formation to occur. New star formation locations show as little blue dots in the image and are dispersed throughout the galaxy, but are notably concentrated in the outer ring. The shock wave's leading edge is marked by the galaxy's outermost ring, which is 1.5 times as large as that of our Milky Way. This object is a spectacular example of the tiny class of ring galaxies. This image is based on the older Hubble data of the Cartwheel galaxy, which was reprocessed in 2010, giving out more detail than previously observed. The James Webb Space Telescope took a considerably more comprehensive image of the Cartwheel galaxy in this next image, where it revealed new insights about the creation of stars and the galaxy's center black hole. Webb's strong infrared vision captured this detailed image of the Cartwheel and two smaller partner galaxies against a background of several other galaxies. This image depicts how the Cartwheel galaxy has evolved over billions of years. The JWST team used data from the telescope's near-infrared and mid-infrared sensors to construct a colorized composite that reveals new regions of disturbance in the formation. Infrared light, which is effectively heat, penetrates dust clouds, enabling the James Webb Space Telescope to see into regions of space that optical telescopes, like Hubble, cannot see. Webb instruments NIRCam and MIRI identified individual stars within the star-forming areas of the Cartwheel galaxy's outer ring, as well as clusters of extremely young stars around the galaxy's center supermassive black hole, which is likewise cloaked in dust in the new images. Webb studies also show areas rich in hydrocarbons and silicate dust, which create the spokes that connect the inner and outer rings. Earlier Hubble photographs revealed the spokes, but the current Webb scans revealed them far more clearly. The Cartwheel galaxy is still changing as a result of the previous collision, and the new observations will help shed light on its history and future evolution. According to NASA, the blue wisps represent areas of star formation, while the eye-catching red spokes represent loose chemical components such as hydrocarbons. The JWST image also shows a textural contrast between the core of the Cartwheel galaxy's extremities. The smooth distribution or form of older star populations and dense dust in the core contrasts sharply with the clumpy morphologies associated with younger star populations outside of it. The galaxy's cartwheeling limbs should become increasingly visible as it expands from the collision zone. The procedure will take a few more years, hundreds of millions to billions of dollars. But we might see some signs of progress the next time JWST aims its gold-plated constellation 22 years later. With the JWST operating as well as it is now, hopefully, we'll see another stellar development of the Cartwheel galaxy in the near future. With the JWST venturing through the cosmos, what other discoveries do you think it's bound to see in the future? Comment below your thoughts and we'll unravel the secrets together. We'll see you then.